Next acidic comparison is this: orthochlorophenol, orthobromophenol, orthoiodophenol. Orthofluorophenol I have not included because it has some different behavior. These three have almost same behavior, so we can discuss them very easily. But fluoro case I will discuss separately, so you can understand it very well. Let's compare their acidic nature. The technique will be same. Once again I am repeating, I am applying second technique. Second technique means I am comparing the stability of anions which is developed after left of H positive ion. You can check it with first method also, strength of OH. The result will be same. Okay. Directly I am going to make anions. Orthochlorophenol anion. Bromo. When chloro, bromo, iodo, fluoro, they make single covalent bond, always they are surrounded with 3 lone pairs. Okay. Let's start the factors. We will compare the stabilities of the anions. The very first factor that you know very well, plus R of O. This factor. This one. And I am not completing the resonance. Please, as a student, you please complete the resonance. Practice is very, very important for you. Due to this plus R of O, the negative charge of oxygen will finish, as you know. So it is a stabilizing factor. I will write here S. S means stabilizing factor. It is decreasing the negative charge, so this factor is making it stable. Same here, it is available. Same here. So in all cases, we have a plus R of O, which is a stabilizing factor. So only by this factor we can't say which is more stable and which is less stable, because the value is almost same. Now second factor. Chlorine is going to show plus R effect or minus R effect. I already told you the technique. If benzene ring and atom connected to it have a lone pair, so it will deliver its lone pair, means it is going to show plus R effect. Means chlorine, bromine, iodine, they all have a lone pairs and they are directly attached to the benzene ring. So they are going to show plus R effect, plus R of Cl, chlorine. Here also we have plus R of Br. Here will be plus R of iodine. And plus R effect of substituent, and because they are present on ortho position. From ortho position, if substituent is operating plus R effect, it is going to destabilize R anion. Why? Already told it to you many a time. Like when it will show resonance, once check again, like this, these pi electrons will be pushed to this carbon. Means on this carbon lone pair will generate. This lone pair will repel the oxygens and carbon electrons toward oxygen side, due to which the negative charge of oxygen will increase. Means this factor will destabilize it. Let's draw it again. Means plus R of Cl is a destabilizing factor. Destabilizing factor. D dot S. D dot S. Destabilizing factor. Okay. Third factor. Chlorine is more electronegative than carbon, as you know. It is more electronegative than carbon, so it will absorb electrons like this. Which effect it is? Minus I effect. Minus I of Cl. Bromine is more electronegative, iodine is more electronegative than carbon, so here we have minus I of Br, and here we have minus I of iodine. And this minus I effect is going to stabilize this anion, because when electron will transfer toward chlorine, so obviously the negative charge of oxygen will decrease. Oxygen's negative charge will decrease. Oxygen negative charge will decrease in all three cases. So can I say it is a stabilizing factor? Yes, it's a stabilizing factor. Stability is inversely proportional to charge. More charge, less stability. Less charge, more stability. Okay. Now let's conclude. First factor, same in all cases. So this is not going to decide the stability order. Go for second one now. Here we have plus R of Cl. Here also we have plus R of Cl, plus R. Third factor, minus I. Plus R is saying ds, means destabilize it. Minus I is saying stabilize it, means two factors are opposite of each other. One is saying destabilize the anion, one is saying stabilize the anion. Who will win? The powerful personality will win. Powerful factor will win. Powerful factor will dominate here. Which factor is dominating or powerful? Now note down. Exceptional. Remember, in previous video I said 99% cases plus R dominates over minus I, and only 1% cases are there in which minus I dominates over plus R. This is that 1% case. Chlorine, bromine, iodine. Minus I effect dominates over plus R effect. Note down. It is a dominating factor here. Dominating means more powerful as compared to plus R. Chlorine, bromine, iodine, minus I effect dominates over plus R. Normally, most cases plus R dominates over minus I, but in chlorine, bromine, iodine, minus I dominates over plus R. Means, if minus I is saying stabilize it, so means overall it will be stabilized. No matter what plus R is saying. Plus R was saying destabilize. Now nobody will listen to plus R, because here who is going to dominate? Minus I. Minus I is the boss. Minus I is saying stabilize it, means it will be stable. It will be stable. It will be stable. Means overall these anions are getting stability. Now the question is, why in 99% cases plus R is dominating, and why in chlorine, bromine, iodine minus I is dominating? Okay, I will answer it, but first let's conclude. What is the final conclusion? First let's conclude, then we will go for reason. Okay. Minus I effect is dominating. Okay, means all three are stabilized. We know minus I effect depends on electronegativity. Out of these three substituent, which is going to show strongest minus I effect? Obviously chlorine. Out of chlorine, bromine, iodine, which is most electronegative? Chlorine. Followed by bromine, and least electronegative is iodine. So chlorine is absorbing electrons strongly by minus I effect and stabilize this oxygen too much. So here the first point you will write minus I is dominating. Second, you will write in the case of chlorine the minus I is strongest. It is strongest. And it is weak because electronegativity of bromine is decreased. We know electronegativity order. In 11th class we have done it. Fluorine is most electronegative among halogens. Then from fluorine to iodine, continuously electronegativity is decreasing. Fluoro, chloro, bromo, iodo. This is the pattern. So here we will have weakest minus I effect. Okay. So which will be the most stable anion? This one. This is most stable. And which will be least stable anion? This one. This is least stable. That's it. This is first. This is second. This is third. So what will be the stability order? Increasing stability order. Will be, which is least one? Third means iodo case, third. Then second, and most stable anion will be first one. This one. So what will be the acidic order of their parent molecule? Why I am calling parent? Because these anions were generated from their parent molecules. This one, this one. Now this parent molecule knows that after release of H positive, I will get most stable anion. So obviously it will be ready to release H positive. That's why easy release means most acidic. So acidic order will follow the same pattern according to the stability of anions generated after loss of H positive ion. So this will be the acidic order. Now let's come to the question again. That's final. This is the end of the comparison of this video. Let's try to find out the answer. Why in chlorobromoido minus I is dominating over plus R. First, we should know what is plus R. Plus R is donation of lone pair in the resonance. Suppose this is the molecule I have, A, B, C. C is carrying lone pair and here we have pi electrons. So this will be the resonance and C is showing here plus R effect. Because during resonance it is donating its lone pair, so it is showing plus R effect. Now for resonance, two conditions are important for resonance. First condition, the lone pair should be parallel to pi electrons. Second condition, size of lone pair orbital should match with pi electrons orbital. For better overlapping. Note down these points, very important to understand this concept. For perfect resonance, these two conditions must be followed by lone pairs. If diagrammatically I show, this is sigma bond between A and B, head-to-head overlapping of the orbitals. You know how pi bonds are generated. Sidewise overlapping. One electron here, one electron here, they will overlap sidewise. Here it is not overlapped properly, but this dotted line is showing they are overlapping. This is pi bond. And if here we have C, which want to participate in resonance, obviously resonance will take part like this. In resonance, the lone pair will take part like this. It will shift pi electrons here. This electron will be further transferred. So next condition will be this. Because A is getting now extra electron of B. B's vacant orbital will be overlapped with C lone pair. New bond will generate here. Pi bond will generate here. This is the resonance. I have not drawn them perfectly overlapped. They are like this, perfectly overlapped. Like this. So draw it by yourself. For understanding, I am drawing them like this. Means C is showing here plus R effect. But for this, two conditions are must. Number one, these orbitals, these all orbitals should be parallel to each other. In benzene ring and this chlorine halogen, X I can write here. These lone pair are parallel, no problem. The first condition, parallel orbitals. Parallel orbitals. We have this condition in halogen case, no problem. Orbitals are parallel. Second condition, you can check, I have made the size of the orbitals almost same. This condition is not available when we have chlorine, bromine, iodine. Check. This is which atom? Carbon. And this is which atom? Chlorine. Now chlorine want to overlap its orbital with the orbital of carbon. But the problem is, if I ask one question to you, in 11th class we have done atomic sizes. Carbon's outermost energy level is second. Carbon atomic number is 6. When you will do its electronic configuration, you will find out 1s2, 2s2, 2p2. The second energy level, second shell it is using. Chlorine atomic number 17. Do its electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p5. The third energy level it is using means the chlorine orbital is bigger as compared to carbon orbital. That's why proper overlapping can't happen. That's why chlorine can't show plus R effect properly. For the proper plus R effect, two conditions I have told you. Number one, orbital should be parallel, which they are, no problem. Second, size should match. Size of orbital should match. It is not there because of atomic sizes. Chlorine atom is bigger as compared to carbon. That's why this orbital sizes are not matching. That's why proper overlapping is not happening. And obviously bromine and iodine, they also don't have a same size of orbitals like carbon. We know from chlorine to iodine, the atomic sizes are increasing. So don't you think atomic sizes will become much bigger as we move toward iodine? So proper overlapping is not there with carbon. Means if I draw them, I'm generally drawing, I will not draw everything, just I need to make you understand. This is the orbital of carbon and this is the orbital of chlorine, lone pair, bigger as compared to carbon. So proper overlapping is not there. As we will go to bromine, this is a vacant orbital of carbon, same size. If I talk about bromine, bromine atomic size is bigger than chlorine. So atomic orbital size will further increase. Can they overlap properly? No chance. And if I talk about iodine, iodine is much bigger than bromine. So its lone pair is like this. Can they overlap? No chance. That's it. That's why chlorine, bromine, iodine can't show plus R effect. That's why their plus R effects are very, very weak, due to which their minus I effects are dominating over them. They can't donate electron properly in resonance, but they can attract electrons due to their higher electronegativity. Means minus I effect dominates over plus R effect of X. X means halogens. Which halogens? Chlorine, bromine, iodine. I hope you got a hint that why I have not included fluorine here. Yes, fluorine and carbon atomic size is almost same. Fluorine can show plus R effect very well as compared to these three. That's why I have not included it. Next comparisons, I will include it. That's it. Thank you very much for watching the video. Next videos, another comparisons.